So hello everyone. Hello. So today we are going to actually see about the generator. So before that, if you haven't watched the previous video, then please link will be in the description. Go and watch that. And this is I'm clearly saying that this is not something that I am teaching. This is I am learning, and this is my process of learning. That how I learn the things. So of course this lecture will be somewhat long, although it will be interesting and. Yeah. So if you and first thing is that thank you all of you, all the 800 subscribers we have reached. So it's quite amazing. It's quite amazing to see 800 subscribers we have today. So that is amazing. Guys, thank you so much. Thank you so much to all of you. And let's move on the lecture now. So today we are going to see about the generator. So what is the generator? It is not the generator which generates the electricity. So it is like the generator is like which generates something. Okay. So we are actually learning about the GAN. So GAN is like generative advanced serial networks. Okay. So generator is there. There is two parts. One is generator and second is a discriminator. So today we are going to see the generator part. What is the generator and all these things? And we are going to do its hands-on learning that how we can do it. So I actually use ChatGPT heavily for learning because it gives me a very good results. Okay. Now, so let's see about the input to the generator will be vector drawn from the multivariate standard. Okay, you can see here, like input to the generator will be a vector. So what will be the input in the generator? Just see this thing, a vector drawn from the multivariate standard normal distribution. So what is this thing? Let's see, guys. I'm just going to copy and paste it here. And I'm also going to search on Google because it will help me to see the diagrams, like any picture they have. So it is like multivariate Gaussian model it have, I think. Let's see. So maybe this is the thing, or you can see this is the graph. Like there are multiple variables. So let's see about that. What is this thing? So, like the multivariate standard normal distribution is a fundamental concept, okay, and it represents how a random variables are correlated and follow a normal distribution with zero means and unit variance. Okay, so somewhat we got the thing got something like it is representing a sort of random variables that are correlated with each other. Like it is connected with each other. That one is varying, then other is also varying, and like you can see here, the multivariate standard normal distribution is denoted something like this, and the marginal distribution. Okay, fine. So it is telling me everything that is important. So what it was, it is in simple terms. So let's see, understand this in simple terms. What is this thing? Like so, it is like looking at a bunch of different things all at once, seeing how they relate to with each other, noticing the pattern, like how they have spread out. And it is the powerful tool to understanding and working of data in many different fields. So that is quite important. Okay. And the output of is the image. Output is an image. First thing is that output is an image. So what is the input? Okay. So input is the vector and okay. And output is the vector, output is the image, okay, and input is the vector. So I hope you got the idea. And what the generator actually does, like generator actually generate this image similar to the data original data set. So it generates and discriminates. So that is how it works. This description may remind you of the decoder of the variational autoencoder. Yes, I hope you have remembered about the autoencoder. If you don't know, like autoencoder is like there is a encoder part and decoder part, and in between them there is a latent space. So something like that. In fact, the generator of the GAN fulfills exactly the same purpose as the decoder. So what it does, like generator is same purpose as the decoder. Like decoder also generates, like from vector, it generates the image. So that is the very same thing. I hope you have learned it. Or if you haven't learned it, not a big issue. I'll be telling the very simple things. And if you want to learn it more, then you can just go in the description, click on the playlist. You can see here playlist. Okay, I'm just showing you. Hold on. I'm just showing you the playlist. Here you can see generative deep learning, and here I have published the 14 videos. So your response are very good. So please go and watch this thing, and then you will have the more clarity that what's going on. Although, yeah. So like the concept of mapping from a latent space back to the original domain is very common. Like I hope you are getting, like from a latent space, we are generating something like image and many different things. So that is quite common. Now you can see the architecture of the generator. So this is like input layer is there, recipe is there, and convolutional 2D transpose is there, batch normalization is there. So like there are a lot of layers, one by one, one by one, one by one. We are seeing this thing. Okay. So like how it is starting actually. You can see a sequence also. Like ReLU batch normalization. Okay. So like here is the code for this thing. So let's copy this code and use it in the Collab notebook. So here is a Collab notebook. Hmm. So like there is a code for this thing. Actually, you can code this thing. Okay, it is quite easy. Just one thing is that how you are going to put the steps. So that is the most important thing. You can just copy it and understand about this thing more. The chat GPT, like this is my way of learning. You can have your own also, but yeah, like you can say here the shape size is 100. Okay, now explanation is there that input data is fed into the network, and shape of the batch size will be okay, 100 features will be there. Okay, then it is actually reshaping that, the transformer layer, then convolutional 2D layer is there, then batch normalization layer is there, ReLU activation and additional blah blah things are there. So it is actually architecture represent the generator part of the convolutional neural network. Okay. So it is actually from the code, it is it is understanding that this is the generator of the GAN. So like there are many people who are researching on GAN itself. So you can also have the research on it if you are more interested in it. I'm thinking for it. I'll be seeing in future whenever I will get more time. Then I will start researching on this thing. Now I'm quite busy with some other work also. So like this code is define the generator neural network, and it is like you know with every code you can know like this is the input layer. Then you can say the reshaping it, then convolutional 2D layer. Then okay. So like you can understand that what the batch normalization does. So what the batch normalization does, what it does. Just see this thing. Is a technique for improve the training stability and speed by normalizing the inputs of the each layer. So what it does, like normalize the input layer and calculate the mean and the standard deviance. deviation of the inputs from each mini batch during the training. So like it have a lot of things there. You can just have a look. Okay. Now we'll be just going to see our brick data set. Actually, we are working on our brick data set. We will be a brick data set. We have, okay. So this is all about the generator code. Like now, now you can see here. Oh, up upsampling versus convolutional 2D transpose. What is the meaning of like it is an alternative to using. Okay, first thing is that this is the thing. Like how you use the stride of 2 in some of the convolutional 2D transpose layers to increase the spatial shape. We are increasing the shape of the tensor as it passes through the network. So why we are doing it? Like one in the original insert then 4, 8, 6. Okay. While decreasing the number of the channel, uh, and finally match one to the grayscale input. So why we are doing this, we'll be searching about it. Like why it is happening, why and what its benefit. Using the stride of two in some conversation while decreasing, like there are increase the spatial shape. Okay, okay. So decrease the number of channel. So you can see here feature expansion and contraction is there. Complexity reduction, feature convergence, sorry, faster convergence, then memory efficiency is there, grayscale output matching is there. So these are the things that we use, and I'm going to upload the Kaggle. So now it is downloading the data. Okay. So I hope you got an idea like using the stride of two along with decreasing the number of channel help in the efficiently increasing the spatial shape of the tensor while maintaining the control over the model. So like why to increase the spatial shape? Why to increase the spatial shape? Like you have to ask the question like why this is happening. Increasing the spatial shape, especially in the context of upsampling, several important things are there like preservation of spatial information, like when data or information come from the neural networks, it tend to lose some information. Okay, for losing that information, not losing that information, we use the what you use we use the stride. Okay, we use the stride of 2 and preservation for enhancing the resolution. You can use it, and feature representation is there. Semantic understanding is there also. Semantic segmentation, contextual information. So main thing is that it can retain the information. Okay, so that is the a good thing. Now cut it, and then okay. So this was the discriminator part. This is what the discriminator part. Now what we'll be doing? We'll be writing the generator part. Generator. Okay. So I am just so what I'm doing, like there are no comments here. You can see here like comments are very few. So I'm just going to add the comments so that you'll be able to understand that what is going on. Okay. And this thing you can get, and you can get on the, like I have shared in the description. So you can just go and see this thing. So not a big issue. And like you can see here now that it is defining the input layer, then input vector in the 4D tensor. Then here it is a convolutional 2D transpose layer, and there's all things are batch normalization is there, liquid value is there. So all these things are there. You can just click here and run it. So this was the whole thing about it. Now let's see about the upsampling versus convolutional 2D transpose. So what does it mean? Just read about it. An alternative to the using the convolutional 2D transpose layers is to instead use an upsampling 2D followed by the normal convolutional 2D with stride 1. Why? Like simply repeats each row, okay, and column in its input in order to double the size. And convolutional 2D with 1 then performs the convolution operation. It has been shown that convolutional 2D transpose method can lead to the artifacts or a small checkerboard pattern. As for the okay. So this can be a issue here. Like it can lead to the small checkerboard patterns in the output image and spoil the quality of the output. Although they are used in most impressive GANs in the literature and have proven to be powerful. Okay, powerful tool. So like this is the image. Okay. What are these methods of sampling plus convolutional 2D and are the acceptable ways to transform back into original image domain and really case testing the okay. So what for more easy understanding what I am doing, like I'm just going to paste it. You know, like book has somewhat lengthy language in it, but you can understand by the chat GPT. Just think like how people were studying before ChatGPT. Like ChatGPT can give you any answer. You don't have to go and search on the Google and to see on the website that the answer is there or not. So like in sort of way, like just see in the short and clear way. So difference between the convolutional 2D and like convolutional 2D transpose is like both upsampling and convolution in one step and learns to fill the gaps between the pixels and potentially leading to the smoother transitions. Okay, like sometimes like one time it happened like I have taught almost 20 or 25 minutes and I haven't recorded the lecture. I haven't started the OBS studio. So like it was really um okay. So like can introduce the artifacts in the output and especially noticeable in deeper layers. Okay. So convolutional 2D transpose is like we'll see. Okay, then upsampling by the repeating the pixel values and then performs the okay. So what is the differences? Like convolutional 2D transpose offers a convenience but may introduce the artifacts. But the upsampling 2D plus convolutional 2D provides an alternative or different trade-offs in the output quality. Right in table in summarized form. Let's see. So like despite the artifacts, okay, and provide the so what is artifacts? Like there is different meaning of artifacts in it, I think. In the context of the image generation, artifacts refers to the undesired patterns. Yes, guys. So this was the artifact about the undesired patterns. So convolutional 2D can give you the undesired patterns, but it can give a better result. Upsampling 2D plus convolutional 2D can give you better result. Okay. And although it can learn to fill the gaps, combine the upsampling and convolution. Okay. So this was the whole thing about this thing. So now in the next lecture, we'll be seeing how to train the DC GAN and we'll be training the DC GAN for the picture and we will be also seeing the results also. We can also analyze the things and all these things. Okay. So this will be the whole thing about okay. So it is going to be long lectures. Of course, long and interesting lectures to see like how the image generation actually happens. Okay. So I hope you liked it. And if you like this video, then You can study with me. You can just download the book. You can see in the thumbnail the title. Okay, and if you like this, then please hit the like button and subscribe the channel for more updates. And here you can also see the various news related to AI. I really update about this news. Like you can see here, the king of LLM is there. Then like Nvidia has revealed this Blackwell GPU, so you can just go and watch. Okay, so this was the whole thing. Thank you so much for guys for listening. Meet you in the next video.